Okay, guys, review day 4 of FRQ problems. Okay, here's 2013 problem number 6. 2013, it was easy here. Consider, well, this is problem number 6. I guess they were being nice to you since it was the end. Consider the differential equation dy over dx equals this. So again, guys, this is y prime. Look, it's a mix of y and x on the other side. I'm thinking separation of variables is coming, maybe because I'm looking into the future. So this is a particular solution to the equation, passes through that point. So guys, that's the initial condition. Okay? Okay. Not a lot of words. Pretty easy. 6th problem of the test. I'm tired. Okay, so what do they want? Write an equation for the line tangent to the graph at that point. So they're looking for y minus y1 equals m x minus x1, where x1 equals 1 and y1 equals 0. All right, that's pretty easy. All right, here we go. So I need y1, which I know, it's 0. I need x1, which I know, it's 1. And I need m. M is f prime of x, x of 1. So it's dy over dx at the point, oops, what's x? Oh, 0. At the point 1 comma 0. So I plug them into this equation up here. I get e to the 0 times 3 times 1 squared minus 6 times 1. Okay, e to the 0 is 1. 1 squared is 1, so it's 3 minus 6. That equals negative 3. That's m. So here I go. Y minus y1, 0, equals negative 3 x minus 1. So I get the equation of the tangent line. Equation of tangent line is y equals negative 3 times x minus 1. Looking over at the solution, they gave 2 points to get to that point. Now, guys, what they want is they want f of 1.2. Okay, they want f of 1.2, so all I do is I plug 1.2 into the equation. That's negative 3 times 0.2. It's negative 0.6. Yeah, that's another point. All right? So that's 3 out of 9 points. Okay, what the heck did they ask for next? Okay, particular solution to the differential equation. They want me to find the particular solution. They want me to find f of x. To get f of x, I'm going to have to take the integral of this, and it's x and y mixed over there. So separation of variables should jump to your head, and that's what we did in the last lesson. I'm going to go to a separate piece of paper because I know this. Well, I know let's be gutsy. Let's see if we can get it in here. Okay. All right. So B. All right. I've got dy over dx equals e to the y 3x squared minus 6x. Okay. I'm going to do separation of variables. Dy over e to the y equals 3x squared minus 6x dx. Okay, so I'm going to take an integral here. Okay, I'm going to take the integral of e to the minus y dy. Okay, remember, when I move it upstairs, I change the sign. Equals the integral of 3x squared minus 6x dx. Okay, this integral. Okay, so if I integrate e to whatever, it's its own integral, but I've got to take the derivative of the inside, which is negative. So that integral is negative e to the minus y. Again, hopefully you guys have watched Predestination by this point in the pandemic, so you understand what's happening here. But if I took this derivative, that derivative is itself e to the minus y, but then I have to take the derivative of the inside, which is negative 1. Negative 1 times that equals positive 1. So that's the integral of that equals the other side, and look, they're being nice. X cubed minus 3x squared plus c. Okay, you're 3 points to there. Now I gotta find c. So I use the initial condition. The initial condition is 1, 0. Okay, so condition 1, 0. So if I do that, I get negative e to the 0, which equals 1, equals 1 cubed minus 3. Hey guys, why did I minus c? That's a plus c, sorry. It wouldn't really matter, but times 1, right? 1 squared plus c. So I get 1 equals 1 minus 3 plus c. And if you do the math, you end up seeing that c equals 1. Wait. Guys, sorry. This is minus 1. Okay? So, I thought that looked weird. Did you think that looked weird? So, I get negative 1 equals negative 2 plus c. So, that's why c equals 1. Okay? Sorry, I missed the negative sign out there. Nobody corrected me. You guys were too silent this time. Okay, so guys, I got this. I have, is that good? We go happy with that? Yeah. So we've got negative e to the minus y equals x cubed minus 3x squared minus 1. Okay? So let's see if we can get y by itself. So I'm going to take the log of both sides. This is going to end up becoming, let's see, hang on. E to the minus y equals negative x cubed plus 3x squared plus 1. Okay. Sorry, the reason I was pausing that a little bit, I was kind of looking at the solutions that was going, and they have an error in the solution. It's pretty funny. Hey guys, find the error in the solution and send me an email. That'll be cute. So at any rate, this is it. E to the minus y equals negative x cubed plus 3x squared plus 1. I'll tell you, they wrote minus 1 there on the solution. So if I convert it to a log, I get negative y equals the natural log of negative x cubed plus 3x squared plus 1. So I just converted this to a log. Okay, kind of like taking a log on both sides. So then y equals the negative natural log of negative x cubed plus 3x squared plus 1. That is the solution. Okay? And they give a little note in the solution, but you don't need it. Here's their solution. Guys, they're kind of chugging along the same way. They found c equals 1, just like I did. But here, guys, when they changed everybody's sign, that was minus 1. Did I mess that up? I hardly apologize. This was a plus there. So then that did become minus. I was trying to do too many things there. So this is minus. And this is minus. So, first mistake I've ever made. So guys, that's the solution. So here when c is plus 1, okay? So I plug in here, when I change everybody's sign, it becomes negative 1. So then minus 1. So that's the answer. So that was a pretty easy problem. It was the two things we were covering Monday and Tuesday of this week. Tangent line approximation, which we're doing today. Separation of variables, which we were doing on Monday, worth 9 points. So pretty easy problem.